All right, greetings everyone. The purpose of this video is to go over the prereq material for section 1.3. As always, this handout I'm about to go over is posted on OneMap if you want to look at it yourself. And I will not be going over all the problems in it just for the sake of time. All right, so the first one here, we're given the graph of a line and we are asked to do a few things. So the first is identify 2 points that lie on the line in the graph, then find the slope of the line, and then use our answers from A and B to find the equation of the line. So part C we're going to do up above. All right, so first thing, finding points. I believe we've done some of this already, but just as a reminder, first of all, I'm going to choose 2 points that's going to be easy to read. So those two that I just circled in the first one there, looks like it's coordinates. Remember, to find the coordinates, you start from the origin, see how much you have to go over left to right, and then up and down. So based on what I see here, the coordinates of that point should be -3, -4. And for the other point up there, we want to be very careful. We have to go over 3. We don't go up or down any, so the output value there is 0. Okay, so now we have our -3, -4, and 3, 0. So those are our 2 points. Next thing then, we need to find the slope of the line. And you may recall that we have a formula for slope. Generally, the way we think about it is y2 minus y sub 1 over x2 minus x sub 1. Now, here we're using x's and y's and kind of assuming that in this problem, our variables are x and y. Now, they might not always be that. So really what we're looking at here usually is your outputs over your inputs, the change in outputs over change in inputs. Now, where did this x2, y2, x1, y1 come from? Right, they come from our points. And just like when we talked about the distance formula, it doesn't matter what which input value we label as x2 or x1. What's important is once we choose one, so let's say we choose x3 here to be x1, or sorry, -3 here to be x1, then the point with it has to be the same affiliated y value. So -4 would have to be our y1, and then 3 would be our x2, and the 0 here would be our y2. All right. So now we can calculate our slope. So we'll plug in those points up here. So the y2, which is 0, minus the y1, which is -4, over the x2, which is 3, minus the x1, which is -3. So 0 minus -4 makes a +4 over 3 minus -3. So the minus makes a plus. So we get 4 over 6, which reduces to 2/3 there. Okay, so the slope of this line is 2/3. And if you recall, slope is what tells us kind of the rate of change of the graph, but also kind of like how much it's angled. So if you notice, and we'll get more into this in chapter 2, but if I go from this point, the 2/3 slope means if I kind of go up 2 and over 3, I get to the next point on the line. But that's not super important right now. All right, the last thing to do then is find the equation of the line. And you may recall that the general equation of a line is y equals mx plus b, where the m, well, that's our slope. And then the b is what we call the vertical intercept. And please ignore the fact that my voice just cracked. So that's the point where it crosses the vertical axis. And there's a couple of different ways to find that. First, we can just look at the graph, and we see that here it is crossing at -2. So that would tell us then that our equation here, and we leave y and x as variables, so that'd be y equals the slope, which is 2/3, x, and then plus the b value, which would be plus -2 or just -2. So that's one way we can see that our slope here, our equation is y equals 2/3 x minus 2. Now another thing we could do instead of that is going back to the y equals mx plus b form. We know the value for m. We just found that. That's the slope. That's 2/3. If we need to find the value for b, Well, what we can do is plug in an x and a y because we have some pairs of those. So for example, we could use this 0.30. So we'll plug that information in. So we'll have the y, which is 0, equals the slope, which is 2/3, times the value for x, which is 3, plus b. 2/3 times 3, or we can make that 3/1. If we multiply that, the 3's will cancel. So we'd have 2/1, which is just 2. So 0 equals 2 plus b. We can solve for b by subtracting 2 from both sides. And when we do that, we will get b equals -2. And so that would again lead to this equation here, where y equals 2/3 x minus 2. Okay? All right, that was kind of a lot of writing, so if you need to back the video up and rewatch some of that again, I completely understand. Okay, next thing we need to look at that will come up in this section is factoring a common factor out of an expression. And another way to think about this is factoring what they call a GCF, so a greatest common factor. So that means, sometimes there's multiple things you can factor out. If you're trying to factor out the GCF, though, you're trying to factor out the largest thing you can. So here's how that works. If we're looking at, and I'm going to zoom in here because this is probably hard to read. All right, so if we're going to factor, say, h cubed plus 2h, we want to look at what is the same between those two. And notice in this case, between h cubed and 2h, they have an h in common, right? And in fact, they only have a single h. The first one has 3, that's what h cubed means, h times h times h. The 2h has just the single h, so we're going to factor that out. And then when we think about is what's left if we take out that h. If we take out an h out of the h cubed, we're left with just h squared. Take the h out of the plus 2h, that'll give us a plus 2. Okay, so this factors to h times h squared plus 2. If you wanted to check that that was correct, what you could do is, since it's h times h squared plus 2, you could use your distributive property, because that h is on the outside. Distribute it back in. And see that h times h squared is h cubed, h times 2 is plus 2h, which is exactly what we started with, right? So that tells us this is the correct factorization there. All right. Cool. Skip problem number 3 for now. It's some practice with function notation as well as finding slopes. And then I want to look at these problems here. So we're asked to perform the operations given. So notice here we have x minus 2, that quantity, times x plus 5. And notice in this case, these are two expressions being multiplied. So the x minus 2 and the x plus 5. And to multiply these, we have to use a technique that you may have seen before called FOIL. Okay, and FOIL is an acronym that stands for first, outer, inner, and last. So let me show how that relates to what we're doing here. So first, that means to multiply the first term in each expression. So we take the x, first x times the second x, that'll give us x squared. The outer, that means to multiply the two outside terms. So the x, first x times the 5, the plus 5, we're going to keep the sign with there. So x times plus 5 gives us plus 5x. The inner then means to multiply the inside terms. So that would be the -2, again keeping the sign, times the x. So give us a -2x. And then to multiply the last, that means multiply the -2 times the positive 5, which that would give us a -10. And then we'll finish this up by just combining some like terms. So notice we have the plus 5x and the minus 2x. This would give us x squared plus 3x minus 10. And that would be what we get from multiplying that out there. Okay. In case you're wondering where FOIL comes from, FOIL is actually just a kind of a different version of the distributive property. So you're really just using the distributive property here, but we do need to make sure we multiply all those different things. The first, outer, inner, last. All right, now on the second part here, the h minus 7 quantity squared, we see that it's being squared, and we know that sometimes when there are variable or exponents on the outside, we can just distribute this, right? So if we do that, we get x squared, or h squared from squaring that, and then the negative 7 squared would give us plus 49, right? So this one will just be h squared plus 49, right? Wrong, okay? Hopefully you all were gasping as I was doing that because that was so incorrect. Well, it wasn't so incorrect, but it is incorrect, okay? And I did that on purpose because that is a common mistake I see students make with this. They see this thing being squared, they just try to distribute the square term, and that does not work. Okay, so to figure this out, we have to first think about what it means to square something. And what that means when you square something is to multiply it by itself. So this means take h minus 7 and multiply it by h minus 7. And now notice what this looks like then is the previous one. So this is where we have two terms being multiplied together, so we have to use our FOIL technique. So we'll do the h times the h, which I meant that to be blue. So the h times the h will be the h squared for the first. The outer is the h times the negative 7, which gives us negative 7h. And the inners, which means the negative 7 times h, which gives us negative 7h. And then the last, which means the negative 7 times the negative 7, which gives us positive 49. And you again look for like terms, so the negative 7h and the negative 7h. Combining those gives us h squared minus 14h plus 49. Okay, and there we go. All right, that's all for now. Thank you for watching.